Greetings, Benjamin J. from BENZTRAINZ with another in the series. Well, continuing my experiments to see how much of these motors pull as far as amps from this 5 amp battery. So on the rail, I've got the burrow crane, and it's basically just the MARX micro motor, forward only micro motor. There's no headlight, there's nothing. It's just the motor itself, pulling exactly the same consist. Now, surprisingly enough, the burrow crane can pull this consist. So let's take this around and see how much the MARX micro motor pulls. Okay, get it going decent speed, and we're pulling 1.5 amps, 1.05 amps. So about 1 amp. So this motor will run 5 full hours with this load. Now you change the load, you'll change the coefficients of how much power it's pulling, of course. Now the MARX MERCURY, surprisingly enough, was pulling 2.4 amps. Of course, it's a much, much older motor, so I'm sure that probably affects its characteristics as far as the power required to pull it or to run it. But as you see, this is staying constant, right about 1 amp, 1.02, 1.05. So no headlight, no nothing, just the motor itself, drawing about 1 amp. So this will run 5 continuous hours on this little battery, on a fully charged battery, of course. So you can imagine how long you can run it on a full-size car battery. You know, 600 amps, 900 amps, 1200 amps. The bigger the battery, the larger the capacity, and of course, the longer you can run anything. But the burrow crane will run 5 continuous hours on this Mighty Max battery. That's not bad. Like I said, the only practical application this has is that you don't need AC power, which gives you lots of opportunities to run trains where there is no power available. Doing demonstrations, for example, or a show somewhere where power isn't available or you don't want to spend your money to buy their power. You could just run your entire layout on a battery and won't cost you anything at all. You take a big car battery in there, you could run these trains all day long. And the average runtime on these, on my layout, like I said, 10, 15 minutes, something like that. And I've never sat here and run these things for hours at a time, at least not the same locomotive. You know, I run it 10, 15 minutes, stop it, run a different rail, run a different locomotive, whatever. For now, I'm just trying to ascertain the power draw on these different motors so I can actually calculate their runtime. So the 2036 and the 2025 will run about 5 hours. This will run about 5 hours. This will run about 4.5 hours, the MARX 400. The Lionel 8410 with the CAN motor will run 20 hours, a significant difference. So obviously, if you're just going to be running a train, this is the one to run because it draws so much less power. Anyway, you add headlights, smoke generators, and of course, your power consumption will go up. Right now, I'm just trying to establish a constant as far as different types of motors. So already I've determined the Lionel motor is far more efficient than the MARX motor. These draw about 1 amp. This draws 1.4, perhaps, something like that, and it's 2 pounds less. This one is a CAN motor and draws 1/4 of an amp, 0.25 amps. So this will run 20 hours. This will run about 4. These will both run 5. The burrow crane will run about 5 hours. And just to do a quick comparison, let me take the burrow crane off. Let's grab the MARX MERCURY. Now, it had the highest power consumption when I tested it earlier. So there's the Mercury, and this is an original pre-war motor. Still running exactly the same consist. All right, let's see what the MARX MERCURY pulls. Now look at the difference. 2.2 amps. Now as it warms up, it'll draw even less, but that's a lot of current. You know, this is drawing twice as much as the 2025, and it weighs about 3 pounds less. So 2.2 amps is taking a lot of current to run that motor. And so far, the Mercury has the highest draw of anything I've tested. Now, I haven't tested the diesels yet, but as you see, even at a fairly slow speed, 2.3 amps. So this one will run less than all of the other ones as far as duration. Oh, I've got a wheel off. That's going to make a tremendous difference. Okay, let's try it now. Okay, 2.1 amps. 2 amps now. 1.95. So even so, this is still drawing more power and weighs 3 pounds less than the 2036 or the 2025. So it's just not a very efficient motor, period. Of course, it is close to 80 years old, but everything I've done so far points to the fact the Lionel motor is a more efficient motor, period. Okay, 2.2 amps. So this will run approximately 3 hours, something like that, on this motor. That's non-stop, of course. So anyway, it's an interesting experiment to see what these different motors pull. And as you see, that stands fairly constant between 2 and 2.2 amps. And like I said, as they get warm, they become more efficient because the bearings get warm and expand, the oil thins out, and the resistance actually goes down. So let's turn this up a bit. Okay, that's running at a good constant steady speed all the way around. This MARX Mercury is old. This is 1935. Now look at that. 2.2, between 2.2 and 2.3 amps. So this draws more than the 2036 or the 2025, pulling exactly the same load. So it's interesting. It's an interesting experiment to see what these motors actually draw. Now on an AC transformer, it doesn't make any difference. You have unlimited power. But it's good to know. This way you can calculate how long you can run each of these individual locomotives. With the 8410 being the winner, 20 hours continuous operation. These, so the 2025, the 2036, about 5 hours. The MARX 400, about 4 hours, 4.5 hours. This one, 3 hours max, something like that, depending on how much it continues to draw. But it was averaging 2.2 amps, whereas the 2025 and the 2036, about 1 amp, which is really surprising because this one weighs close to 5 pounds. This one weighs a good 3 pounds. This weighs 2 pounds less, about 3 pounds less, and it's drawing twice as much power. This weighs actually nothing. It's drawing 1 amp. The MARX 400 draws about 1.2 to 1.4 amps. And of course, the 8410, a 1/4 amp. So the CAN motors obviously draw much, much less. Anyway, it's been an interesting experiment. I just wanted to document this, all running off this little Mighty Max battery. And like I said, the only advantage you have of running any of these on a battery is just the fact you don't need AC power. But it's efficient. It's very practical if you're going someplace where there is no power available. You know, you can take your power with you. Just take a good sized car battery or a deep cycle marine battery. You can run these things for days on a standard battery using this little 12-volt controller. So I'm calling the experiment a complete and total success. This works really, really well. Anyway, I'll do a couple tests with the diesels and see what they pull. Of course, the larger the motor and the heavier the locomotive and the longer the consist, the more current it's going to draw. Just kind of looking for an average right now, all done with the same consist. All of these locomotives. So this one draws more than any of the other ones, which is really surprising. Anyway, I just want to do a quick video on this. As always, if you have any questions, feel free to drop me an email, BENZTRAINZ@gmail.com. And as always, thank you for watching.